Welcome to Lesson Up, math tips, tricks, and other ideas. To help continue expanding this site, don't forget to subscribe and like. I once had a student who had just returned from a camping trip with 5 of his friends. One night, while they were sitting around the campfire, he proclaimed, "Free beer to anyone who can guess how many different ways we could sit around the fire." After a few raucous guesses, he revealed there are 720 different ways, explaining that the counting method is called a permutation and that the number of ways can be expressed as 6 factorial. When he told me this story, well, I shook my head a little and mentioned that he was actually incorrect. Arranging individuals in a circle, such as sitting around a campfire, is known as circular permutation. The correct number from his camping trip is 5 factorial, or 120 different ways. Perplexed, the student asked me to explain. I said, imagine your younger sister is making a bracelet with 6 different colored beads. As she threads the beads onto the band in a line, we know there are 6 factorial different ways she can arrange them. If we designate the first bead of the string as a pivot point, we can demonstrate that this bead could have been strung to any of the 6 positions on the band. Thus, the total number of permutations can be expressed as 6 times 5 factorial. Now suppose your sister connects the ends of the band to form the bracelet. Once the bracelet is connected, it forms a circular arrangement. If we disconnect the bracelet at a different point and open it up, it appears the pivot bead has shifted positions. This apparent shift happens no matter where the bracelet is disconnected. If we disconnect the last section, it seems as though the pivot bead has shifted from the original first position on the band to the last position. Since our pivot bead is not shifting in our circular connection, then the number of ways the 6 beads can be arranged in a circle is not 6 factorial. Though we started with 6 times 5 factorial when the beads were first strung linearly, this linear behavior does not apply in a circle. So rather than a multiple of 6, we have division of 6. Thus, for linear permutations, the number of arrangements of distinct items is n factorial. However, each circular arrangement appears n times in that count. Therefore, we divide by n. This is expressed as n minus 1 factorial. Now that the student understood circular permutations, I added one more twist. Once his sister connects the bracelet, there are 2 different ways she can place it on her wrist. With that understanding, can he determine how many distinct arrangements of the beads there really are? If you'd like to try this problem on your own, you should pause this video now. We must keep in mind that a bracelet can be flipped over when slipping it onto your wrist, so each circular arrangement has a reflection. Reflections don't create another arrangement of the beads, we're just viewing it from the other side. Thus, both perspectives are from the same circular arrangement. Now, for individuals sitting around a campfire, there are no reflections, so each circular arrangement is distinct. So there is definitely n minus 1 factorial arrangements. However, circular arrangements of objects such as a bracelet has a mirror image, and those 2 are really the same design. That means each arrangement has been counted twice. So instead of n minus 1 factorial, we divide by 2. For his sister's bracelet, this would be 60 distinct arrangements. To help continue expanding this site, don't forget to subscribe and like. See you next time.